Human bacterial colonization. How does it all begin? There is a consensus that in utero, the baby is in a sterile environment. However, at birth, there is an assault on all mucosal surfaces, including the skin. So the intestines of babies at birth contain largely facultative anaerobes such as the enterococci and the bifidobacteria. But as the child then is weaned from the mother's breast milk towards plant polysaccharides, say, there is a change in the gastrointestinal flora that now includes the Bacteroides families of bacteria as well as the Streptococci, for example. These are obligate anaerobes. It is generally reported that an infant acquires full adult colonization of the gastrointestinal tract at about 2 years of age. So therefore, a brief overview for the next few slides will show the interaction of bacteria with the intestines and why it is so important for the development of gastrointestinal tract homeostasis. Now, the stomach is fundamentally a sterile organ. Any bacteria that are ingested, unless one is on an acid blocker, the low pH of 1 destroys any bacteria that have been normally ingested. As we move into the small bowel, the proximal small bowel has a concentration of about 100,000 cells per milliliter of fluid, and as we move to the distal small bowel, this increases to about 100 million cells per milliliter of fluid. Then as we move into the large bowel, there's a significant jump in concentration of bacterial cells of the order of about 100 billion cells per milliliter of fluid. Now, we really do not have too many studies on how infants get colonized over time. We also don't have as of yet a good bacterial fingerprint of the stools to let us know really what is a good bacterial profile versus what is a bad bacterial profile. However, based on in vitro and animal studies, the scientists tell us that there are beneficial effects versus harmful effects. Like, for example, the lactobacillus and bifidobacteria upregulate the immune system. Harmful bacteria such as Clostridia, Klebsiella produce toxins that, if one is allergic to such molecules, may then produce an inflammatory response that is of the allergic type, and if the particular individual is susceptible to a continued insult for these bacterial toxins, may then go on to increasing risk in developing inflammatory bowel conditions such as ulcerative colitis or Crohn's disease.